G'day from Australia. I'd just like to start with a little bit of a custom that we have here in Australia. I want to begin by thanking or acknowledging the traditional owners of the land from which I'm broadcasting this live stream. I'd also like to pay my respects to elders past and present. We're all going through some really challenging times at the moment, so wherever you are in the world listening to this, I really hope that you're doing okay and that you're staying safe. My name is Ashley Davis, and I'm the author of Bootstrapping Microservices. Welcome to my home office. I work here almost every day, especially since the pandemic started. And today I'm going to be talking to you about infrastructure as code. First, we're going to start with a little bit of theory, and then we're going to do like a practical demonstration so you can really understand how you can use infrastructure as code using a tool called Terraform. I'm just going to start my screen, share my screen with you now so that you can see my slides. I'll start with a little bit about myself. I'm the CTO of a company called Sortle, and we're a startup that has built a product that can help you organize all your digital assets through the magic of machine learning. I'm also the developer of a product called Dataforge Notebook. It's like Jupyter Notebook, but it's for JavaScript and TypeScript. You can prototype your code with live visualizations and later export your code to run it in production. I've written 2 books with Manning. My first book is Data Wrangling with JavaScript. Data Wrangling with JavaScript, I wrote that so that as a JavaScript developer, you can see that you don't need to go to Python to have to work with data. Everything you need is already available in JavaScript. You just need to learn how to use it. And of course, my latest book is Bootstrapping Microservices. It's a practical and project-based guide to building applications with microservices using all the latest tools like Docker, Kubernetes, and Terraform. In this book, I lead you through the process of building a small but complete microservices application. We start very simply, creating a single microservice and then packaging and publishing it using Docker. Then we ramp up to multiple microservices and simulate a complete microservices application locally on our development workstation using Docker Compose. Eventually, we get to creating a Kubernetes cluster using Terraform, and we deploy our microservices to it. So the content you're going to see in the presentation and the demonstration today, it's very much related to this book. In fact, in chapter 6 of the book is where we build the Kubernetes cluster, and then in chapter 7 we deploy to that cluster. So if you'd like to see more of what I show you today and in more detail and with me guiding you through the process, you can definitely find that in my book Bootstrapping Microservices. Please hang about until the end of this presentation and I'll be giving away some discount codes so that you can get the book for a bit cheaper. So before we get into the theory, I'm just going to give you a little bit of a demo, a little bit of a taster of where we're going to get to at the end of this. So the end result of this is we want to be able to kind of update our infrastructure through code, and we want to do that basically by pushing code to our hosted code repository, having our continuous delivery pipeline automatically kick in and do the work for us. And I'm just going to show you what that looks like. Just allow me to get my demo set up. So I've prepared some example code for today's demonstration. You can find it on Bitbucket, Bootstrapping Microservices. Bitbucket is a little bit like GitHub. It's a place where you can host your code repositories. I've got 2 example code repositories here, example 1 and example 2. Originally, I was going to go through both of these code examples, but we're probably not going to have time in this live stream. So today we're just going to be looking at example 1. Which is an example of using Terraform to build a Kubernetes cluster on Microsoft Azure. And then example 2 is an example of how to build and deploy a microservice to that Kubernetes cluster. So we're mostly just going to be looking at example 1 today. I'm just going to drill down to that. So this is a code repository. You can see here a bunch of example code. Anything ending in a TF file is a Terraform code file. We're going to be looking at the code in there a little bit later, and I'm going to be explaining, how it fits together and what it means. For the moment, I just want to show you the end product, which is the continuous delivery pipeline in action. If I click on the pipelines tab here, you can see all the continuous delivery pipelines that have been invoked for this code repository. Obviously, there's been quite a few because I've been practicing for this demo. Now, this code repo, it's just like super simple. It's not a complicated infrastructure, but it's good for learning, and it's good for practicing, and it's good for demonstrations like this. So at the start of this, back on the original page, on the first invocation of this continuous delivery pipeline, that was where the original Kubernetes cluster was created. So what I have now here is an existing Kubernetes cluster, and what I want to do is I want to update it through code. So I've already got a local copy of the code, which I've opened in Visual Studio Code here. This file is kubernetescluster.tf. Oh, by the way, if you do want to follow on, you probably won't be able to keep up with me live, but you can get this code repository later. You can clone this, or you can just download this directly from here, and you can follow along. Let's just go back into that pipelines tab. I have to be in the pipelines tab just to show you what it's going to do. So back to the code. This is the configuration of my Kubernetes cluster. I've got it set up with a node pool that just has one virtual machine. So this is a Kubernetes cluster that's powered by one virtual machine, not a very big cluster. We want to make this a little bit more powerful. We can change the node count to 2. I'm just going to save that. Now I'll flip back to my terminal here. I'm actually running this on Windows 10 today, but all the commands I'm going to show you will work on Linux and Mac OS. I've actually got git bash installed, and that comes with a whole bunch of Linux commands that you can use under Windows Terminal. So it's a really nice setup, and it works cross-platform. So you can see here I've done an ls. You can see all the Terraform files that I've got. The one that I just changed is this kubernetescluster.tf. Now what I'm going to do, I'm using git for version control. I'm just going to see what I've changed. I've changed one thing. Like a good developer on any team, I'm going to diff my change just to make sure that I'm not breaking anything. So you can see here that I've changed the node count from 1 to 2. I'm going to commit this change. Put a nice commit comment. And now I'm going to push this to my hosted code repository. Now what you'll see now is that this is going to initiate a pipeline. So you can see we've got a pipeline pending here. And it's got my commit comment, scaling up the cluster to 2 nodes. Now it's in progress. We can drill down into this and see what it's doing. You can see here it's running a shell script called deploy.sh. This is something that's important. I'm going to show you this shell script a bit later. You can see here in the output of the shell script that it's running Terraform. And indeed, it's actually now talking to Azure. So you can see down here at the bottom of the output, it's talking to Azure. It's making changes to my live Kubernetes cluster, and it's updating the cluster for me. Anyway, by the time this finishes, we're not going to wait for it to finish. We're just going to, get on with some theory and then the full demonstration. This is just really a taster to show you what infrastructure as code is all about. It's you make a change to your code, you push the change, and it automatically updates your infrastructure for you. So I'm just going to leave that running, and we'll continue on. So that was just a taste of where we're headed today and where we're going to get to by the end of this. We're going to be looking at, obviously the theme of this talk is infrastructure as code. We're going to understand what it is, why you would want to use it, and how to use it. We'll be using Terraform as the tool and the configuration language to implement infrastructure as code. And I'll be giving you a live demonstration of how we can run Terraform locally to create infrastructure in the cloud, and then how we wire that into our continuous delivery pipeline to then put it on automatic. Before diving into infrastructure as code, let's briefly take a step back and understand what I mean when I say infrastructure. Infrastructure is simply the platform on which we run our application. For this particular example, The application is one that I built using microservices because, that's what I do. That's what I wrote my book about. It doesn't have to be this way, of course. This is just one particular example. You can see in the diagram that we have a bunch of microservices running on a Kubernetes cluster, which is hosted in the cloud. You can see off to the left that a user is interacting with our application through a front end in a web browser. Now this talk, it's not about front end stuff at all. You could replace that web browser there with a mobile application. It doesn't really matter how the front end is delivered. What I'm talking about today is back end. It's completely server side, nothing to do with the front end. But typically, the application that you put on your infrastructure is going to be accessible through a web browser or through a mobile app, or maybe through a native desktop application even. The infrastructure in this example is running on a Kubernetes cluster, and that's the computing platform that our application is running on. So Kubernetes is an orchestration platform that allows you to run containers, and I use it for my projects to run microservices. If you want to build an application like this, the first question you need to ask is, how are you going to build the infrastructure? How are we going to build this Kubernetes cluster? Now, we could build the infrastructure manually, and what I mean is that we could go into the web portal for our favorite cloud vendor and we could create a Kubernetes cluster using the GUI. Or we could also build it using the command line tools from our cloud vendor. That's a really great way of doing it as well. And in fact, if you want to try doing this manually using command line tools, I have a blog post for that. If you go to my blog, actually I've already got this open. My blog is the Data Wrangler. If you scroll down a bit, you can see here the quick guide to creating a Kubernetes cluster. If you drill through that, it will show you the quickest sequence of steps to manually create a Kubernetes cluster on Microsoft Azure using the command line. Anyway, I'm getting a little bit sidetracked. We'll get back to the slides. I'll make a link to my blog available later as well in case you missed that. Now, it's perfectly okay to start a new application by manually creating your infrastructure. Building infrastructure manually, it's a good way to learn. It's a good way to practice your skills. It might also be all that you need. Like if you're building a small application, which has a small infrastructure that isn't going to change much in the future, then it's completely okay for you to do that manually. If you are building that small application and you don't see it as changing, you don't really need to automate your deployments. Now, most infrastructures aren't going to be like that, of course, in the modern world with modern applications. And there's a bunch of problems with manual deployment. As you might imagine, the applications we're building these days are growing ever more complex. And as a result, the deployment is getting more and more complicated as well. And the more complicated you make the deployment, the more potential there is for human error. The risk of error means that the manual process isn't very repeatable. It's also very labor intensive. So if you need to do multiple deployments and you have an actual person going through all the steps all the time, it's going to be pretty time consuming, not to mention boring. And if it's boring, the person likely won't be paying as much attention as they should, and that further increases the risk of mistakes. Ultimately, manual deployment, it just isn't very scalable. As your infrastructure grows bigger and more complicated, manual deployment is just going to work less well for you. Of course, the cure for manual deployment is, of course, to automate it. We'd like to make our deployments reliable. We can only do that by taking the human out of the equation. Automation also makes our deployments more efficient. And why would we want to pay or pay a human to spend hours doing something that a machine can do in minutes? Automation also makes the process repeatable, and that means we can make multiple copies of our infrastructure if we need to. That can be useful for performance and fault tolerance. And being able to make new copies of our infrastructure on demand is really useful for safely releasing new updates to our customers. It means that we can employ a technique called blue-green deployment that utilizes 2 copies of our infrastructure. It's also useful for us to be able to make multiple environments. So often on a software development team, we find it useful to be able to create multiple instances of our infrastructure. And for example, we'd like to have an instance for development, a separate instance for testing, and a completely separate instance for our customers, so that they can, use only the tested version of the application. Having automated deployment means that as a last resort, if we have infrastructure that's not working so badly that we can't fix it, we can simply nuke it and run our scripts again to recreate it. Now that is completely a last resort option, but it's something that automated deployment allows, and it's quite amazing, really. In the end, we need automated deployment for scalability. The amount of time it takes a human to build the infrastructure, it's no longer, and it should no longer be a constraint for application design. The software industry has moved well beyond that. Now we can automate our deployments, and that means we can deploy whenever and wherever we like and as often as we like, without having to wait for a human to put in the hours that would have been required before we automated it. So that brings us to infrastructure as code. And to make a long story short, infrastructure as code, it's simply the technique where we manage infrastructure creation and updating and management through code instead of creating that infrastructure manually. In a moment, I'm going to explain a little bit deeper about infrastructure as code, but for the moment, let's just take a look at this diagram and we'll understand what I'm going to demonstrate today. You can see the developer on the left here is using Terraform locally on their development workstation. They're invoking the Terraform tool to run their infrastructure code, and that code is reaching out to the cloud to create and update their cloud-based infrastructure. In the demonstration today, I'm going to be showing how to use Terraform to create a Kubernetes cluster on Azure. And the process in this diagram, actually, it shows you the way that I prototype real infrastructure. I write and test code on my local computer, and that code is then making changes to the infrastructure in the cloud. This diagram shows where we'd like to end up with infrastructure as code. You can see the developer here on the left is writing and testing his code locally, and they're committing code to their local Git repository. When they push code, their hosted repository is automatically triggering the continuous delivery pipeline. In this example, we're using Terraform inside the pipeline. It's running the code and it's creating or updating the infrastructure in the cloud. Terraform's not the only tool you could use here. You could build your own tools. There's other tools you could use. This diagram shows a simplified pipeline. There's no checks or balances in it. You can't see any automated tests here. Typically in a real pipeline, you'd have those things, and you'd have multiple stages for possibly for manual approvals. And whatever other testing, automated compliance testing, automated security testing, whatever other testing you want to have in your pipeline to be sure that safe code is getting rolled out to production. So I've really simplified this for today's demonstration. It doesn't include any of that, and it's a lot simpler than it could be. This pipeline makes for a complete automated flow of infrastructure changes from the developer all the way through into production. And hopefully you can see here, why it's called infrastructure as code. It's the act of changing code that triggers the pipeline that is what makes changes to our infrastructure. Once we have a pipeline like this in place, we're now updating our infrastructure through code changes. So I'm just going to get into a little bit more detail now about infrastructure as code. We'll dive a bit deeper. So infrastructure as code, it's where we manage our infrastructure through code. Not only is our code the source of truth about our application, but it can become now the source of truth about our infrastructure. And rather than being a manual or physical task, the act of creating infrastructure has been converted to a coding task. So anything that's useful for coding suddenly becomes useful for building infrastructure. That's important because we've already amassed a large toolkit of techniques for coding that we can now apply to creating infrastructure. Infrastructure as code usually means that the management of our infrastructure is automated. And this is a huge win for any modern business that is trying to scale up. Because what we want to do, we want to grow our application to support our expanding customer base, and we can't scale to any large extent without automation. Infrastructure as code then, it provides part of the basis that basically paves the way for massive scalability. Why should we use infrastructure as code? It's all about the automation. We're automating the creation and maintenance of our infrastructure, and that has many positive benefits. Automation can really empower a small team. It's what allows us to achieve big scalability with only a small workforce. It reduces the amount of manual work we must do, and this in turn frees up time for us to work on the features that are important to our customers. It reduces the risk of human error. Again, this frees up time because errors usually involve quite a bit of time to correct. The fact is that automation makes deployments cheaper, and this is what makes small deployments more cost effective. And actually, this is one of the reasons why microservices have exploded in popularity recently, because they have become cost effective to build and run. So all this serves basically to reduce the risk that any one deployment will fail. And infrastructure as code, it's making our updates more reliable, the process is faster and more repeatable, and the knock-on effect is that we can safely increase the frequency of our deployments, and thus we get more features more quickly into the hands of customers. So we're increasing the pace at which we roll out features. And that's of course the reason why we're doing any of this. We are delivering application features to our customers, and anything that streamlines that, makes it safer, makes it faster, that's going to give our business a competitive advantage. Because of infrastructure as code, because our infrastructure code is the source of truth about our application, the code is acting like a kind of a documentation. It documents the way our application or our infrastructure is supposed to work. And it not only describes it, but also running the code is what brings our infrastructure up to date. So we know that our documentation, or this infrastructure code as documentation, is always going to be up to date because it reflects what we have in production. Another big reason to use infrastructure as code is because it makes a coding activity out of infrastructure management. Because it becomes a coding task, we apply all the tools that we normally use while coding. Things like automated testing. We can use that time and time again to automatically validate that our code is working correctly. We can use version control to manage versioning of our infrastructure. I think as developers, we often take version control for granted. But it's amazing, really. It allows for a kind of time travel. Like we can go back into the past using version control, and we can reconstitute our infrastructure as it was in the past. That's really useful if you want to reproduce a bug or a feature or something like that from the past. You can also use version control to roll back changes, maybe broken changes, roll back to a working version. We can use branches and labels to manage different versions of our infrastructure. And one of my favorite things actually is to use a test branch that deploys to the test infrastructure, a dev branch that deploys to the dev infrastructure, and a prod branch that deploys to the production infrastructure. So we can manage multiple instances of our infrastructure using version control. And of course, infrastructure as code, it's a key enabler for continuous delivery. And that is what allows us to automate the deployment of our infrastructure. So the question now is, how do we make use of it? As with anything in our industry, there's so many different ways we could do this. There's many different tools we could use. And of course, today I'm focusing on Terraform, which is one tool we can use for infrastructure as code. We'd like to have our infrastructure defined in code so that we can put it on automatic in a continuous delivery pipeline. And for that, we need to trigger it using a version control system. Of course, I'm going to be using Git. That's the modern industry standard for version control. All that we need to do now is choose a cloud vendor. I'm going to be using Azure. I'll tell you more about that in a second. But why Terraform? Why would you want to use Terraform for something like this? Terraform makes it easy to reliably and repeatedly configure cloud infrastructure. It's a declarative language, which means you describe, what you want rather than how you want it built. So it's much easier to code than say an imperative infrastructure as code language. It's incredibly flexible. Its functionality is extended through plugin providers, and that means it's multi-vendor. It works with any cloud. So you can use Terraform with, I'm going to be showing today how we use it with Azure. You can use it with AWS, you can use it with Google Cloud, and some of the smaller vendors as well. To seal the deal, Terraform also supports the ability to configure, the internals of your Kubernetes cluster. So you can roll out containers, you can deploy microservices to your cluster using Terraform. Terraform is really smart. So as I said, it's declarative. So it figures out how to create what you're asking for, the sequence of steps to go through to create that. And it gets even smarter, because once you've got existing infrastructure and you want to make changes to it, all you have to do, you don't have to do any kind of step-by-step migration of your infrastructure. You just change your code so it is the way you want it to be next. You run Terraform. Terraform figures out, what is the difference? What is the delta between what it was and what you want it to be? And it applies those changes. To top it all off, Terraform is open source. So if you wanted to, you could actually, get into that code base and contribute to it. As I mentioned, Terraform works with any cloud vendor, but to demonstrate, I need to pick a side. I like Azure. I've got a fair bit of experience with it, so that's why I'm going with Azure. It's one of the big three, of course, so it's one of the ones that you would pick. But I find Azure is pretty beginner friendly. It's pretty easy to use. I think that's how Microsoft are really competing against AWS, is in usability. And when you sign up for the first time, you get $200 starting credit. So you've got a bit of time to experiment before you start spending cash. Now you've got to make sure you clean up all your cloud resources after you've done your experimentation, of course, because you don't want to burn your credit, and after that you don't want to burn your cash. So I'm going to be showing today how to deploy a Kubernetes cluster on Azure using Terraform. Now it's demo time. Please start your prayers to the demo gods for me while I just get set up. So again, we're just going to go back to the code repo where we started today. Again, just starting at bitbucket.org, Bootstrapping Microservices, drilling down to example 1. You can get this code for yourself. If you want to try this out for yourself, you can clone the repo here, or you can download it as a zip file here. I'm going to start from scratch. So I'm going to approach this just the way you would if you were following along. So I'm going to clone this. I'm going to copy that command line there. I'm going to clone this. Hopefully it won't take too long. Yep, that's great. I'll change directory into that example 1 project so I can run commands there. You can see I've got all my Terraform code files here ready for us to look at. As I said, I'm using Windows 10 here, but I have got Linux commands installed through Git Bash. So the commands I'm showing you here should work on Linux, also Mac OS. I've actually got all the software, all the tools that I need installed. So I have Terraform installed already. I can show you that. I can run it. I can get the version number here. You can install Terraform yourself really easily. So literally just go into Google, go install Terraform, pick the first link. That'll give you instructions to install the Terraform tool, and it can be installed on any platform. So it doesn't matter whether you got Windows, Linux, or Mac OS. You can get this installed. Now, because I'm creating infrastructure on Azure, I also have to have the Azure command line installed. That's as. So you can see the version that I've got running here. Now, again, really easy to get this for yourself. You just go into Google, install Azure CLI, pick the first link, and you get instructions here on how to install it for all the different platforms. Now, I'm going to just open Visual Studio Code on this directory. Zoom in a bit. Hopefully everyone can see that okay. Now, before I can test this locally, so I'm not yet running this in the continuous delivery pipeline. But to test it locally, I just have to comment out the contents of this file. This is what connects the. It's actually set up for continuous delivery. So this is what connects the continuous delivery pipeline to the Azure storage backend. That's basically persisting the storage from pipeline to pipeline. It's a little bit easier to run locally for this demonstration if I just comment that out. So that's just commented out for the moment. And now I can get set up to run Terraform. The first thing I need to do is run Terraform Init. So this initializes the Terraform project that's in this directory, downloading the plugins like Azure here that I need installed to run this code. You only need to do this once, and then you can run the code multiple times, but you only have to initialize once, or you have to initialize when you add new plugins. Now, while that's going, I'm just going to show you providers.tf, which is where I store my configuration for the Terraform provider plugins. You can see here the Azure plugin is defined here. So this is just declaring that my code needs this plugin and which version I need. And also the TLS plugin, which I use for creating some private and public keys there. You don't need this file. When you're first starting out with Terraform, you don't need this. Like, you just write Terraform code, and Terraform is going to figure out what providers you need, and it's going to automatically install the latest versions. But when you get to production, you kind of need this file. You need to fix your version numbers so that they don't bump the version number and kind of give you a breaking change. You don't want any nasty surprises like that. So I'll just switch back to my terminal. So something's gone wrong. It's I don't know if the demo gods are pleased with me at the moment. Let me try that again. Maybe it was just an intermittent issue. Better just check my internet. I'm still connected. I'm using mobile internet. Oh, there we go. That's good. So I now have my Terraform project initialized. Now, before I can actually run the Terraform code, I need to be authenticated with Azure. I've done that. You can do that with the as login command. That steps you through what you need to do to authenticate with your Azure account. If you also, to run Azure Apply, you need to create, for this example anyway, you need to create an Azure Service Principal. I've already done that, but if you need to do that yourself, you can find some instructions in the README for this code repository. If you scroll down to the README here, there's a section here called Azure Authentication, and it gives you the commands you need to create your Service Principal. That's like an account in Azure that is going to allow our cluster to talk to Azure to do things like creating load balancers. So I've done that. I'm now authenticated with Azure. I've set that up earlier. I have created an Azure Service Principal. Now I'm just going to run Terraform Apply to run this code. This is going to create the Kubernetes cluster. So this is what's going to reach out to Azure. It's going to create the Kubernetes cluster. It's going to take about 5 minutes. In that time, we're going to actually kind of have a look at some of the Terraform code and understand what it does. So let's kick this off. Now, the first thing is it's asking me a question here. It's asking me what is app_name. Now, this is a variable in my Terraform code that I don't provide a default value for, and that means I need to explicitly provide a value for it here. I do this because this is how I create multiple instances of this infrastructure. So I can run this code as many times as I like to make as many different clusters as I like, as long as they have different names. So I'm just using ISE demo 1 for this. Now this is where I have to enter the details of my Azure Service Principal. Just give me a second while I find them. So I get my client ID in there, I get my client secret. These are the kind of details you shouldn't really give away on the internet, but I'm going to be deleting the service principal in a few minutes, so it's not going to be a huge deal. So Terraform is like thinking now about what it's going to do. It's kind of looked at my code, it's figuring out what it's got to do to create this cluster. If you look back through the output, you can kind of see, it shows you what its plan is basically. This is what it's planning to do. It's going to create a container registry. That's somewhere where we can basically publish our images, our Docker images for our microservices. We're not making use of that in today's demo, but it is part of example 2, which I might do later in another live stream. So these are all the details here for the container registry. You can see here it's creating a Kubernetes cluster, and we've got all the configuration here for the Kubernetes cluster, which version we're using. You can see down here we've got two nodes, so 2 virtual machines in this cluster, and that's because if you remember at the start of this demo I had changed this code from 1 to 2. That's why we've got 2 there at the moment. So the rest of the configuration here for Kubernetes. Now it hasn't actually done anything yet. It's waiting for me to approve this, so it's kind of expecting you to look at the plan, say that it's okay to create all this cloud infrastructure, and then type yes. So now it's actually talking to Azure, and it's going through the process of creating this Kubernetes cluster. As I said, this is going to take about 5 minutes, so we're not just going to sit here and watch it, and this is the perfect time for us to actually have a look at the Terraform code for this example 1. Now we started with this file backup.tf, and I had to comment this out. This is part of the continuous delivery configuration because each instance or each invocation of the continuous delivery pipeline is completely separate, and Terraform likes to know its state between invocations. So this setup here is very minimal. You'll see the rest of it in a moment, what sort of feeds into this, but this is what connects it to Azure storage so that the continuous delivery pipeline can remember where it was last time, basically. Now the other file that we looked at already was providers.tf. This is just, the names of all these files are completely arbitrary, by the way. Like, you don't have to name this file providers.tf. It's a code file. You can name it whatever you want. But this is, conventionally where I store the configurations of my providers. In this case, it's just version numbers. There's nothing else. But in some cases, for other providers, there's other configuration details that you have to provide. Now, also by convention, I have a file called variables.tf, and this is where I store my Terraform global variables. You can see here there's the app name variable that we just have to type at the command line. It's empty, so there's no default value in here, which is why you're forced to type it at the command line. There's a location variable. We've set that to West US. You can set that to whichever data center you want for Azure. The username for the Linux box. And client ID and client secret. So these are the details for the Azure Service Principal that we typed in before. This is like an authentication account that allows this cluster to connect to talk to the Azure API and make changes, like things like creating a load balancer. Now, the next file here is to look at is resourcegroup.tf. So this creates an Azure resource group. It's creating it with the same name that we plugged in for app name and the location where we want this to be. And Azure resource group is just like allows you a way basically to collect together all your cloud resources in a way where they can be managed together. So we're adding all the resources we're creating as part of this in this Terraform code are going to go in this resource group. The file privatekey.tf, this is using the TLS private key resource. This allows us to create a public-private private key pair that you can use to basically authenticate with the cluster once it's ready, once it's created. Now the main event, the Kubernetes cluster.tf file. So this is where we are defining the cluster. You can see here we're passing in the app name as the name of the cluster, we're passing in the location. There's other details here. We're specifying which version of Kubernetes we want to run. We're using the private key, public key here as the authentication for the nodes that we've got running there. We're defining the default node pool here. So this is where we set the number of virtual machines that run this cluster. And this is where we set the size of the virtual machine. So here I'm opting for the smallest size or the cheapest Azure VM that can host a Kubernetes cluster. It's not necessarily what you'd use for production. For production, you might want to use something a little bit bigger than that. We're wiring in the details of our service principal. Again, we're connecting through this service principal, through this sort of authenticated account, we're connecting the Kubernetes cluster with Azure. And now we've got some outputs here. So we're going to be able to look at these in a moment in the output from Terraform. So creating an output in Terraform, it will actually print that to the terminal. So we're getting details out here from our script about the keys that we created and authentication details for our cluster. So this will give us in the output like everything we need to know to connect to our Kubernetes cluster. Let's see how that command is going. It's finished. Awesome. So you can see here, after I've run Terraform apply to run the Terraform code, we've got a shitload of output here, like all the keys and stuff that we need to get into the cluster, authentication details for our private container registry. Now, what I want to do is, so if Terraform finishes like this, and there's no errors, it should mean that we've got a cluster ready to go, and it's working. But I just like to test it anyway. So what we could do now is we can use kubectl. That's the Kubernetes CLI tool to connect to our cluster and interact with it and run some tests on it. To do that, we need to kind of set up a configuration file in our .kube directory, in our home directory. And you would basically set it up by copying some of these keys into it. That's a little bit messy, a little bit painful. I'm not going to do that. What I am going to do is Azure provides a really useful, really convenient command called get credentials that will download the authentication details for our Kubernetes cluster and put them in our configuration file and set them up for us. So hopefully I've typed all this right. Yep, I'm just going to overwrite my existing configuration file. So now I've got a Kubernetes configuration file in my user directory that allows me to connect to this cluster that I just created. So I can actually run kubectl. I'm just going to show you the version that I've got, kubectl version. So this is just a command line tool for interacting with Kubernetes. Again, like any of these things that I'm showing you, you can just get this literally by saying install kubectl. Click the first link. Now you get instructions here on how to install kubectl for your platform, whatever that may be. So I've got kubectl. I'm going to run kubectl get nodes. So this will list the virtual machines that are powering the Kubernetes cluster. As you can see here, I've got 2 virtual machines. Now, what I want to do now is I just want to show you that I can make a local code change to my code, run Terraform apply, and then update this cluster. So let's just say I'm working on a prototype or an MVP or a personal project, something like that. I don't want to pay for 2 nodes, so I'm just going to set it back to 1 node. Now, I've made a code change to my Terraform code. If I run Terraform apply again, it's going to run that code. It's going to update my cluster. I just have to enter the same details that I entered before. Just give me a moment. Okay, so this is probably going to take a few minutes, but what this is doing now is it's kind of looking at my code, and it's comparing what's in my code to the current state of my cluster. So it's looking at the cluster and saying, oh, that's got 2 nodes, and my code says it only should have 1. So it's going to figure out like what it needs to do to make that change. And as before, it gives us a plan. So this is the plan of what it's going to do. You can peruse this, but the important thing to note here is where it's showing you what it's changed. If I can just find that, here it is. So it's saying that the node count is going to go from 2 to 1. So you have to say, yep, that's the change I was expecting to go out to my infrastructure. Hit yes, and now it's actually going to reach out and it's actually going to make that change to the Kubernetes cluster. This could take a few minutes. I'm just going to switch back to the code. And we're going to see now how this fits into continuous delivery. If you remember earlier when I showed you how the continuous delivery pipeline in Bitbucket was running a shell script called deploy.sh, here is that shell script. So we've simply got a shell script in our code repository that we're going to run from continuous delivery. And you can see here all that we're doing, the core of what we're doing here is we're running Terraform Init and Terraform Apply, just like we just did from the command line on our development PC. Now, this is a really important thing to note and a really useful way to understand continuous delivery. I like to think of continuous delivery as simply an automated way to run a shell script in the cloud. Continuous delivery is just a shell script. That's a simplification. I'm dumbing it down a bit, but I think it can really help people understand what continuous delivery is. Now, there's a bunch of other stuff here where we're wiring in a bunch of configuration here so that Terraform can remember its state from invocation to invocation of the continuous delivery pipeline. We're passing in some environment variables here to set variables in our Terraform code. These environment variables, they come from the Bitbucket dashboard. So you've got a secure place in Bitbucket where you can go and enter variables against your account or against a particular code repository, and you don't have to keep sensitive details like these authentication details. You don't have to keep them in your code. And you'll also note that we're using the auto-approve flag here as well. So a continuous delivery pipeline is going to be running automatically. There's going to be no humans involved. There's no one there to type yes to approve it. So we have to use auto-approve here to make sure that this goes through. So that's really it. That's what continuous delivery really boils down to. For me, it's just a shell script. Or running any command really, or any group of commands. It doesn't really have to be a shell script. But I usually like to make a shell script out of it, and I do that because then I can debug it locally. I can actually run the shell script locally on my development PC, and I know that I'm running the same sort of thing that's then later going to be running in the cloud in the continuous delivery pipeline. Okay, let's take a quick look back at the terminal to see if that's finished. No, it's still going through the process. It's still modifying that existing Kubernetes cluster. So there's one last thing I can show you here anyway, and it's the one last piece of the puzzle about how this fits into the continuous delivery pipeline. Now, if you want to make if you want to do this yourself, you can. You have to make an account with Bitbucket. They have a free tier, so you can actually do this and get your continuous delivery pipeline online, and it's not going to cost you anything to do some experimentation. You just need to take this code that I've shown you here, example 1, create a new repo in your own Bitbucket account, upload your code, then you go into the Bitbucket pipelines dashboard for that repository, and you enable Bitbucket pipelines. That's just the switch that you enable in the GUI. And then you have to have this file here, bitbucketpipelines.configure.yaml. So this is the continuous delivery pipeline configuration. If you have this in your repo and you have Bitbucket pipelines turned on, every time you push your code, it's going to run this configuration for you and run your pipeline. Now, you can see up the top here we're specifying a Docker image to base our pipeline off. We're using Terraform. So this base Terraform Docker image includes all the Terraform tools that we need to run Terraform in our deployment pipeline. And then all we're doing, I mean, there's not much to this, right? And this is simplified. I get it. If you're doing this in a production enterprise system, it's going to be more complicated, but it can be as simple as this, right? We're just running a shell script. We're just running deploy.sh. So, and if you look back in there, we're just running Terraform Init and Terraform Apply. And Terraform is then running our code. So we've got a fair bit of Terraform code there. Terraform is then connecting to the Azure API and building the Kubernetes cluster or updating the Kubernetes cluster on our behalf. So that's connecting all the dots from local coding all the way to pushing your code and having it automatically trigger a continuous delivery pipeline. Now let's just have a quick look back here. Are we finished? So we basically got the same output as before here. But this time I can run kube control get nodes, and we've only got one VM. Now, just to be clear, this Kubernetes cluster that I've created from the terminal, like live in front of you, that's different to the Kubernetes cluster that's being updated by the continuous delivery pipeline. So I've actually got two different clusters in play here with two different names. But generally speaking, I can have as many clusters as I want. I could make a new cluster right now doing this. I could run Terraform apply, and I could type a new name in here. If I type a unique name and I run this, I'm going to get a completely new cluster that's independent. And I can talk to either cluster. I can have authentication details for either cluster. So this is sort of the way that you can use Terraform to make multiple environments. Now, the last thing I want to do here is I just want to show you how to quickly get the Kubernetes dashboard up, so you can see visually what's happening in your cluster with just let me copy the command. The command to do this is really big, so I'm just going to copy it over. Now, the managed Kubernetes cluster on Azure used to automatically provide the dashboard. They don't do that anymore. You have to install it yourself. You could do this with Terraform, but I'm just going to do it the old-fashioned or the kind of the normal way, and send a YAML file to the Kubernetes API through kubectl. So this is installing the dashboard. Once I've installed the Kubernetes dashboard, I mean, it's probably going to take a couple of moments to start up, but I can run kubectl proxy. So this opens a tunnel, like a secure tunnel into my cluster, so that I can access my cluster from localhost. Now you can get to the Kubernetes API that way if you want to make REST API calls to it, but you can also get to the dashboard this way. I'll show you what it looks like. So I've got to type in this massive long command. I can't remember that, so I just copied and pasted that. Now, it's going to ask me to authenticate. I already have a local kube config file that I can use to authenticate. That was already set up for me a few minutes ago. I just have to drill down to the kube config file here, plug that in, click sign in. And now I'm in the dashboard. This is really cool for understanding like what's happening inside your Kubernetes cluster. If I had stuff running here, which I don't, you could see it under pods here. Let me zoom in a little bit. So there's no pods, there's no containers running here, there's no microservices yet. That will be the next live stream where I show you how to actually do that. But you can look at some interesting stuff here, like under nodes. You can see that I've got one node here. You'll recall that we started with 2 virtual machines and we changed it to 1. When there was 2 here, we could have seen 2. This is the equivalent, by the way. This is the equivalent of doing kubectl get nodes. So it shows you, and you can drill down to look at the details of each virtual machine. So you can see that this was created 14 minutes ago. This is the one that I literally just created. You can look at things like CPU usage, memory usage, all sorts of stuff is running on this node, but mostly it's Kubernetes system containers, or Kubernetes, the dashboard that we just installed is running on there now as well. But you know, literally anything that you've got running in your cluster, you can find it through the dashboard. And you can even, the dashboard, even when you're getting started with Kubernetes, the dashboard is a great way to kind of feel your way around. You can actually create stuff in here. You can actually deploy containers through the UI into your cluster. I recommend that you don't work that way in production. You should be using infrastructure as code for that. But doing things manually is a great way to play around with it, a great way to feel your way around the system and understand what's going on there. Now, just before we finish the demonstration, one last thing. I'm going to destroy this cluster. So I don't want to pay for this to keep running. Obviously, it's not going to be any use to me, after this demonstration. So I'm running Terraform Destroy. If I put in the exact same parameters here, let me just find my service principal authentication again. If I use the exact same parameters here, it's going to destroy that cluster that I just created. Now, as per usual, it's kind of looking at what we've got in Azure. It's looking what we want to do, which is what we want to do is destroy everything that we created. It's going to take just a couple of moments to do that. We'll just wait for that to finish so I can approve it. So again, it's kind of in the output here, it's telling you what it's going to delete, what it's going to destroy. If you're happy with that, you can type yes. And now this is going to take a few minutes. We're not going to watch this complete, but what it's doing now is it's kind of running the Terraform code to kind of reach out and destroy everything that we just created. So you can think of this as like a development cluster. You know, this isn't a production cluster, it's a development or a test cluster, and you know, we can kill it when we don't need to use it anymore. So that's it from me for today. In conclusion, I'd just like to sum up by saying infrastructure as code, you know, it's just a way to manage infrastructure through coding where you can automate it. You can develop and test your code locally, and the automation happens through a continuous delivery pipeline, like what I've demonstrated today in Bitbucket pipelines. And if there's anything I want you to take away, it's that continuous delivery, the way I think of it, it's just running a shell script automatically in the cloud. There's nothing particularly complicated about it. Of course, the particular shell script or the particular Terraform scripts could get quite complicated, but as you've seen today, you know, you can start off from a really simple starting point. And that really helps when you get started and you're just playing around, you're just trying to, you know, figure out how all this stuff works. It's a great way to get started. Finally, infrastructure as code, it's just one of those things that is helping make microservices more cost effective than ever before to run. And so you can make the most out of the microservices architecture, and it's very, very affordable. So this talk and this demonstration has really just given you a bit of a taste of what you can do with infrastructure as code. If you'd like to explore the bigger picture of building a microservices application with modern tooling, you can't go past my book, Bootstrapping Microservices. It's very practical and straightforward. I'm going to walk you through the whole process of building an application, you know, all the way from building a single microservice, publishing it in your private container registry, and then all the way through to using infrastructure as code to build a Kubernetes cluster and deploy your application to it. I keep things as simple as possible in this book, and in the example application, it's not overwhelming, it's easily understandable, and you can easily get it running for yourself in the cloud. We're using microservices like in a simple sense. You know, we've simplified it so we can understand it, so we can bootstrap microservices and really get started with it. But at the end of the day, you're still using microservices, so you still have these pathways to scalability that you get with microservices. You can see here there's a link to the book. There's a discount code there for 40% off, and there's a link to the example code. I'm going to tweet these slides later, and I'm going to tweet some links to these resources as well. So if you're here and you've missed this, just get on my Twitter and you'll find the details there. Thanks so much everyone for joining me today. Please stay safe.